Take two. You're looking at the EDU2AE. On the front screen, when you first turn the power, you'll see the version number 1.1. As of April 2nd, 2013, this is the most current firmware revision for this controller. The system ready on the bottom indicates you're ready to run the driver. When you run the driver, it defaults to the operator screen, where you see the model number of driver that you have programmed in, what joint you are assembling, whether it be a soft or a hard joint, the speed that the driver is running or set to run at, the torque percentage that is set in the menu. When you squeeze the lever, you go from a ready state to a tightening state. When you go into reverse, it will say loosening. And if you run a joint down, you'll see a screw OK signal come up with the green light. If the joint were bad, you'll get red light, and it will tell you what the error was. In the menu, press and hold Escape. The first line tells you the model. You can change that by pressing the OK button and using the up and down arrow keys to select the specific model that you have attached. We have everything from Pluto 3 all the way up to the Pluto 35, and then we go into the Pluto 3 FRs all the way up to the Pluto 7 FRs. Those are the mechanical clutch Pluto tools. The torque percentage is set to 20%. This is a percentage of power that is being applied to the tool. It is not the actual torque value. The actual torque value will have to be determined with a torque analyzer. This percentage, like I said, is output power from the controller and the tool. If you need a specific value, again, you need to use a torque analyzer. The joint setting. We can select either a hard joint or a soft joint. In this specific case, I have a soft joint selected. Soft joint is where you have compression. If you have a lock washer or thick gasketing material that has a certain amount of give to it when it's tightened, that is a soft joint. A hard joint would be where you had a metal fastener going to a metal plate and there's not any give in the joint. That would be a hard joint. There are some variations in the middle, of course. Those are discussed in a different segment. Break time. Break time allows you to run most of the screw into position prior to what we would determine to be the control speed for torque. When hard joint is selected, we have an internal charted speed for the specific amount of torque you are asking the driver to develop. And using the brake time allows the driver to run at full speed for a specific amount of time to run most of the screw into place. At which point, when the brake time is over, the control speed takes over to develop the torque. Now, if it takes 1 second to run the screw fully into place, you can set your brake time for, say, 3/4 of a second, and then allow that last quarter second to run the control speed. Ramp time, this is what some people will call a soft start. We have to have a minimum of 0.2 seconds to get the motor and the rest of the driver actually running. We do rely on the inertia of the moving parts in the driver to help develop the torque. So we need to at least get the motor moving. So the minimum you'll see is 0.2. The rest of it you can move up to as much as you want. Let's say I do 1.25 seconds for my ramp time. It'll take the driver 1.25 seconds to achieve the full speed that I'm asking it to deliver. Speed, this is in soft joint, this will be continuous throughout the entire operation. Right now it's set at 920 RPMs, and this can be adjusted by, again, pressing OK and using the up and down arrow keys. In hard joint, this speed would be shut off at the end of brake time. In other words, it'll use the internal charted speed for whatever power you're asking it to deliver. The minimum time. This is the minimum time that you are allowing the driver to run for your specific joint. Let's say it takes 1 second to run your screw into place. If you have a minimum time of 0.9 and then have a maximum time of, say, 1.2, yes, it takes a little while to get down. We'll say 1.3. Okay, so I have a min time of 0.9 and a max time of 0.3. If I have not reached my minimum time, I most likely cross-threaded the screw and the joint will be no good. If I run over the max time, I most likely stripped out the threads, and again the joint is no good. So those are time parameters that we allow us to process control. Auto reverse. There are some applications where someone would want to tighten a fastener into place and then back off. Our feature is actually time controlled. If you hit OK, this control is in time. So for 0.3 seconds, this feature will automatically reverse the driver for 0.3 seconds. You can use that time feature to determine how far backed off you'd like that fastener to be. Reverse speed goes with the auto reverse, or if you use the reverse switch on the tool, that'll be your maximum speed. Reverse torque, you can actually change the amount of power put into the tool at the time you're reversing. The default is maximum, and that will remove most fasteners. You can limit that if your process requires it. The last thing that you have that you can change is the language, and then we have the number of cycles on line 13. Right now this controller's only run 2 cycles so far. And that's the complete menu. If you have any questions about the actual use of this controller, please give us a call or send us an email. Thank you.